talk about the last thing in probability, which is called conditional probability. So in the previous lecture we talked about the notion of independence. So let's just say we had two independent events, A and B. Okay, that means that one event does not affect the outcome of the other. So the notion of conditional probability involves the following. So what this is saying is, if event B happens, given event A, what would the probability be? Since A and B are independent, given that A occurs has no effect on the probability of B. So if two events are independent, the probability of B, given that A occurs, is just the probability of B. Now let's assume that these events are not independent. Okay, so A and B are dependent. So if we want to find the probability of B given, again this is given, that event A occurs, we would write it like the following. The probability of B given that A occurs is the probability of A and B over the probability of A. So what does this symbol mean? This symbol right here. And I'm sorry, the notation was wrong. This symbol means intersection. So probability of A intersection B is the same as probability of A and B. Okay? So again, if B and A are independent, then event A has no effect on event B, so it's just the probability of B. And this one is for A and B independent. Because, again, given that A occurs has no effect on the outcome of probability, or the outcome of B. another definition of conditional probability is that there's a condition that limits the sample space. So let's look at an example. We are trying to find the probability that a person under the age of 30 listens to rap. Okay. So again, we're trying to find the probability that given a person is under the age of 30 that they do listen to rap. Okay? So how are we going to do that? Well, when you're given this information in what is called a two-way table, you're going to have to somehow limit the sample space. So since we're given that the person is under the age of 30, we're only concerned with this group right here. This one right here. So among those, how many listen to rap? It's going to equal 10, right? Because 10 listen to rap out of a total of 22, which is 5 out of 11. So given that a person is under the age of 30, the probability that they listen to rap is 5 out of 11. Now how can we find this information using the definition of conditional probability? By definition, the probability of A given B is the probability of A and B over the probability of the given. So the probability that they do listen to rap and they're under 30 is just this right here. It's 10 out of, there are a total of 37 possible outcomes. Okay? And the probability that they're under 30 is this right here. It's 22 out of 37. So when we simplify this fraction by multiplying by the reciprocal, okay, these two cancel out and we're left with 10 over 22, which is 5 over 11. So either way we look at this problem, we get the same answer. Let's talk about another type of problem. This involves tree diagrams. So there are two coaches Coach George and Coach Tom. We're interested in knowing how likely it is to get a scholarship given you have one of these coaches. So let's just say, for example, the probability that you get a scholarship given you have Coach Tom is 0.8. Okay. And also in the problem you're given that the probability of getting Coach George is 0.6, and the probability that you get a scholarship given you have Coach George is 0.9. Okay, so this is the information that's given to you in the problem. The question you're asked is find the probability that you get Coach George and you get a scholarship. That's question number 1. Question number 2 is find the probability that you get a scholarship. And question number 3 is find the probability that given you got a scholarship you had Coach Tom. These are the 3 questions we're trying to answer. So anytime you're given information like this, you know you need to set up a tree diagram. So in our case, we can either have Coach Tom or we can have Coach George. Okay, and we know these values. Right? We know the probability of getting Coach Tom is 1 minus the probability of getting Coach George, which is 0.4. That's how we got this 0.4. And the probability of Coach George is 0.6, because there are only 2 coaches. Now we break it down even further into whether or not you receive a scholarship having those coaches. So given that you have Coach Tom, what's the probability of getting a scholarship? So we're given that information in the problem. This is 0.8. The probability that you don't get a scholarship, and we'll denote that by n, given that you have Coach Tom, is 1 minus this probability. So that's going to be 1 minus 0.8, which is 0.2. Now the probability that you get a scholarship given that you have Coach George, that's given to you in the problem, that's 0.9. So the probability that you don't get a scholarship given you have Coach George, that's going to be 0.1. Okay, so now how are we going to find each of these probabilities up here? So let's start with the first one. And what I'm going to do is I'm going to try to clear up some room here. deleting all of this. And then I'm going to delete some of this as well. Apologize for the delay. Okay, and let's move this. Oh, no, rotate it. Sorry about this. Okay. Alright, so now let's work on number 1. Probability that we had Coach George and we got a scholarship. The probability that we had Coach George and that we got a scholarship is the following. The probability, remember the probability of G and S is going to be the probability of G times the probability that we got a scholarship given that we had Coach George. Okay, so that's going to be 0.6 times 0.9. And why don't we go ahead and just figure out what the probability of getting a scholarship and having Coach Tom. That would be the probability of having Coach Tom times the probability of getting a scholarship given we had Coach Tom. And that is going to equal 0.4 times 0.8. We got that from here. Okay, so we got this information from here and this information from right here. So we know these two quantities and we can write those down. .54 and this one is 0.32. Okay, second, what is the probability that you get a scholarship? The probability that you get a scholarship is the probability that you had Coach George and you got a scholarship, or you had Coach Tom and you got a scholarship. Okay. Again, it's the probability that you got a scholarship is the probability that you got Coach Tom and you got a scholarship. So you went down this branch, and we can highlight that in yellow. So this path. Or you had Coach George and you got a scholarship. So it's 0.6 and 0.9, which is this right here, and 0.4 and 0.8, which is this path right here, over here. So the sum of these two is going to be 0.86. So at this high school, you have a 86% chance of getting a scholarship, which is very good. So either coach you have, it matters, but not by very much. The third question and final question is, let's just say you're given the information that you got a scholarship. What is the likelihood that you had Coach Tom? So how are we going to find this information? So to find this information, we have to use the following. Okay? So the probability of find the probability of having Coach Tom given that you got a scholarship. That's the probability that you had Coach Tom and you got a scholarship over the probability that you had a scholarship. The probability that you had a scholarship is what we found right here, 0.86. So it's going to be 0.86 in the denominator. And in the numerator you have this quantity, 0.32. So when you divide these two, you get the answer, which is 0.372. Okay, so if we had to write that as a percent, it would be 37.2%, which is close to a 1 in 3 chance. So given that you got a scholarship, there was a 1 in 3 chance that you had Coach Tom. Hope you all learned something new. Thank you for listening.